About research in general, I love the open-endedness of it. The fact that you don't have a set goal that you're going towards and when you reach it you win, but instead you can define your own goals and you can really proceed along different paths than maybe you initially thought you were going to. We make capsules that self-assemble in solution. So they dissolve in water, for example. So this one here is a tetrahedron. This one here is a cube. They often have high symmetry, but they don't need to. And they're hollow. They bind things inside. And the space inside of these capsules is very different than the space outside in free solution. So things inside may react differently. They may be prevented from reacting, or they may be transported into solutions that they might otherwise not go into. So you can change chemical behavior through encapsulation of individual molecules, I think, in some very interesting ways. I think the most exciting applications we have right now in mind have to do with chemical separations. So right now, if you want to separate apart chemicals, valuable chemicals, either things like drugs or monomers that you're going to use to make high-value polymers, you usually have to distill them apart or do something else that involves a lot of energy input. If you can recognize individual molecules out of a mixture and transport them to a place where you can release them in pure form, you might be able to cut a lot of energy out of separations processes and maybe get purer product out at the end as well. One project involves having cages that can move from one phase to another under the influence of stimuli such as light or heat. So you can potentially pick up some cargo in one phase, say petroleum, move that compound in pure form to another phase where you can then release it and potentially use it. I think this will be important as we move away from taking petroleum out of the ground as something to burn and move much more towards using it as this wealth of different chemical compounds that you can do different things with as building blocks, as opposed to things to burn. We have a project on self-assembling polymers that can conduct electricity and that change their electrical resistance in response to an electrical field being put across them. So they can remember something about the electrical state that they're in. You can use them as a kind of memory. They remember by shrinking physically, and so they might be able to act as a kind of artificial muscle. We talked to several people over in physics, including Richard Friend's group and Ulrich Kaiser's group. Another project we have involves using cages to recognize specific sequences of DNA and potentially deliver cargoes to those sequences of DNA. So there's relevance there, I guess, in therapeutics, ultimately. We also have collaborations with other people in other universities around the world, in Italy and France, a few people in the States, in Japan. So yeah, we love talking to other people, and I think the best ideas come out of these conversations, where it's not just somebody sitting in a room and thinking, but actually people interacting. I've wandered quite a bit. I've lived in several different countries, and I find Cambridge singular in terms of the environment for people who are not necessarily from here. There are lots of people from all around the world, and they all come together. We all come together to make a community, I think, in a remarkable way. It's a good environment to be a foreigner in, I think. And it's a great environment to bring together people from many different cultural backgrounds. I think in these zones of confluence of different cultural streams, you can come up with some really interesting new ideas. They emerge out of these sort of whirlpools.